All right. So the first thing is when you're taking this test, remember you have 25 questions, you have an hour to take it, and you can miss 2 and still pass. So the goal here, though, is to try and get everything right 100%. And that's what we're going to try and do. The first thing is you need to make sure you read the questions, make sure you know what the things are asking you. A lot of these are pretty straightforward in the beginning, and then they get a little bit more nuanced as you kind of go down further into the exam. If there are the test, if there are, and there are a few things that you need to know off the top of your head. And I recommended that you, and I recommended this last week, that you write these things down before you take your test. And those are your equivalents or your conversions. So you should know how to go from milligrams to grams, how to go from micrograms to milligrams, milliliters to liters, ounces to milliliters, pounds to kilograms. You need to know how to do those things because you're going to be asked how to do that on this test, as this mock test shows. So what I'm going to do is I'm just going to go through and work through these. The first question here is about the 1.75 grams to milligrams. So there's a couple ways you can do this. You can move your decimal point over 1, 2, 3 places, and then your answer would just be 1,750 milligrams. No rounding, that's your answer. If you're not confident with moving your decimal point over, the alternative way is doing what's called dimensional analysis. 1.75 grams times your conversion factor. We don't want grams, we do want milligrams, and we know that there are 1,000 milligrams in a gram. And you know, before you do any kind of math, you've set this up right because you can cancel out your units. You're left with the unit of interest, milligrams, and you'll get the same answer, 1,750 milligrams. And you may be wondering, do I need to put a comma? I don't think that that's necessary. I haven't seen anyone asking about that. All right, for the 250 milliliters to liters, I'm going to do the same strategy. My decimal's here. I can move it over 1, 2, 3 spots, and my answer would be 0.25 liters. If you don't feel confident moving your decimal point over, you're going to take your 250 milliliters over 1, multiply by your conversion factor. So you don't want milliliters, you do want liters. You know that there's 1,000 milliliters in a liter. So notice that the 1,000 is the consistent thing here, but the difference is the unit of measure. So we get rid of the milliliters. We're left with what we're looking for, liters, and we're going to get an answer of 0.25 liters. So you want to write that into, or make sure when you're doing that, that you or that when you write your answers, make sure you're indicating your units. I forgot to do it here. Make sure you're writing it where it's appropriate. Sometimes the unit's already given to you. And then if you are doing this as a Blackboard test, you may not need to include the units. You may just need to include the number. So just make sure you read the directions depending on how you're taking it. All right. So again, and also you notice that I left it at 0.25. Even if this was 0.275, even if this was 0.2755, I would leave that alone. I would not round my basic unit conversions. Don't round when you're in the metric system, just doing a unit conversion. Do not round your basic unit conversions. When you go from different systems, though, so from the imperial system or household units to the metric system, you will want to round when necessary. Now, there's a couple ways to do this. You can set up an equation if you want to, but this is just dividing by 2.2. Okay. And when you do that you do probably need your calculator for. 128 divided by 2.2 will give you 58.18181818. It just is a repeating number. That's your clue that you're going to round that. And because it's a number greater than 1, you're going to round that to 58.2 kilograms. Round to the nearest tenth if it's greater than 1. Round to the nearest hundredth if it's less than 1. And again, rounding is applicable to pretty much everything, excluding when you're doing your basic unit conversions, such as going from grams to milligrams, micrograms, milligrams, and so on and so forth. All right. 90 milliliters to ounces. One of the things you need to know, and I'll just write it over here, is that 1 ounce is equivalent to 30 milliliters. Okay. So that's something you need to know before you even take the test, that you're required to know that. They're not going to give that to you. Okay. So if once I know my conversion, I can just set up again using dimensional analysis. I don't want milliliters, right? But I do want ounces. And I know that 1 ounce is the same thing as 30 milliliters. So 90 divided by 30. And I'm going to get 3 ounces. If this was like, if you, for some reason you got 3.25 ounces, you would round that to the nearest tenth because you're going from the metric system to the imperial system or the household system. So because you're going between different units of measure, you would go ahead and round your answer. Lastly, this is going from micrograms to milligrams. If you already know, you can take your decimal point and move it 3 to the left, and you'll see that you'll get an answer of 0.025. That is the answer. You do not round because why? Because we're in the metric system going into the metric system. Okay. And then if you needed to see that from a dimensional analysis standpoint, you start off with 25 micrograms. But you don't want micrograms. You want milligrams. 1 milligram is the same thing as 1,000 micrograms. And you get 0.025 milligrams. And that's helpful to know just in case you're sitting there and you get stuck, or you don't remember how to do the moving of the decimal point. This should at least help out with that. Okay. Oh, you know what? I think this test doesn't have the input questions on it. That's okay. We can go back to that at some point. So, all right. This is one of those things where you want to remember to read the question. Okay, so it says you administer 250 milligrams of dilantin. Then it asks how many teaspoons will you administer given the label below. So we're going to look at our order, 250 milligrams. PO just means by mouth. And then we need to make sure we put it into teaspoons. Okay. It says what we have available is dilantin 125. It's oral suspension. And then you'll see 125 milligrams per milliliter is the available dose, or or your equivalent or your conversion factor if you use those terms. Okay. Now, when you get down to the medications, most of these you can just go ahead and do order over have, or order over available times quantity. And that will, you should get those all right following that particular format. You can also use dimensional analysis. I will, just for simplicity's sake, just show order over available for these. But if you want to see, if somebody wants to see the dimensional analysis of a particular problem, just let me know and I will certainly do that. Now I'm going to show you 2 ways to do this particular problem because of the teaspoon thing. So the first way, doing order over have, is I'm going to take my 250 milligrams over what I have, 125 milligrams, times my quantity of 5 milliliters. So 250 over 125 is 2. Times 5 is 10. So if I was just solving for milliliters, my answer for this would be 10 milliliters. Then I would convert milliliters to teaspoons. Again, you already need to know what that conversion is. 1 teaspoon is equivalent to 5 milliliters. And so that gives you an answer of 2 teaspoons. The alternative way is, since you already know that 1 teaspoon is 5 milliliters, you can substitute this 5 milliliters. You can substitute that with 1 teaspoon. And so when I set up my initial problem, I can set it up the same way: 250 milligrams, 125 milligrams. And then instead of multiplying by 5 ml, I just multiply by 1 teaspoon, and I'll get 2 teaspoons. Okay, so all I did was I substituted these because they are equivalents, right? So that's all I did. These are the ones that you'll prefer to do because they are a little bit more straightforward. You probably have a little bit more experience with just capsules and tablets and things like that. So this tells us that we have an order of 500 milligrams by mouth, BID, which means 2 times per day. Then it says how many capsules do you give per day. So that's important. So you're used to calculating per dose, but this question asks you how many per day. Okay. So what I'm going to do is I'm going to calculate my initial, or what my per dose is first. So my order is the 500 milligrams. My available is 250 milligrams, and that's per capsule, which gives me 2 capsules per dose. And since I'm going to give that dose twice, you're just going to multiply it by 2. Okay, so make sure you read what the question asks, because sometimes it'll say how much to give. If it just says how much to give, it's per dose. And then usually it'll tell you per dose, or sometimes it'll tell you per day. All right. This question, the commonly missed thing is you didn't circle the correct amount on the cup. So make sure you mark your cup. Okay. And I'll show you the couple different ways that you might want to mark it. You want to confirm with your instructor how they want you to mark the cups and the syringes. And then if it's on Blackboard, you probably won't even have to worry about it. Okay. So what's my order? 40 milliequivalents by mouth QID. So 40 milliequivalents by mouth QID, which means 4 times a day with juice. And your available is potassium chloride, 20 milliequivalents per 15 milliliters. Okay. So we're going to set this up, and this is where dimensional analysis is helpful, but not necessary. I can just still do order over half. You just need to wrap your head around the fact that a milliequivalent is the same thing as like a milligram or a microgram or a milliliter, or not milliliter. We'll just stick with milligram or microgram. It's just a different unit of measure. Okay. So what I'm going to do is I'm going to take my order, just like I always do, divide it by what I have available, and multiply by my quantity. Notice that it's 15 this time, or a tablespoon, as opposed to 5 or 1 milliliter. So make sure you just plug in what what the numbers that they tell you. So 40 over 20 is 2 times 15 is 30 milliliters. I will also tell you that your answer most likely will be on the cup. So since it says to circle the correct amount on the cup, I would circle my 30 milliliters and notice that it's the same thing as 2 tablespoons. If you ever get stuck, you can see that some of your equivalents are listed here. So teaspoon is 5 milliliters, tablespoon is 15 milliliters. So you can see that they're listed there if you needed to. If they asked you to like mark the cup so that like it looks like it's full, then you would just shade in the cup. But the directions here say to circle the correct amount. All right. This is another, anytime you see SC or IM, you know that you're going to be dealing with milliliters because these are injectables. Okay, so you're injecting a liquid. So you see our order is heparin 3,000 units. You can see that we have available 10,000 units per milliliter. So I'm going to set this up the same way I've been setting all these up, 3,000 units. So remember, units, just like milliequivalents, just like milligrams and micrograms, just a unit of measure over the 10,000 units times your quantity, which is 1 milliliter. Now, if you, a little shorthand, if you're concerned that you might not put this into your calculator correctly, look at the number of zeros. There's 3 on 3,000 and there's 4 and 10,000. Take the least number, the fewer number, so 3. I'm going to cross them out and cross out the 3 here. And now you have 3 over 10, which is the same thing as 3,000 over 10,000, which will give you an answer of 0. It's supposed to be a 0.3 milliliters. Then you would look at your Tubex. So basically, it's just like a syringe. And you look to see, okay, this is half a milliliter, which is the same thing as 0.5. Let's just see, make sure these are in increments of tenths. So 0.5, 0.6, 0.7, 0.8, 0.9, 1. Okay, so we know this is 0.5, so this is 0.4. This would be 0.3. So they might ask you to circle it. They might ask you to mark it, but that would be your 0.3 milliliters on your Tubex. And the only reason I'm circling is because that's what this direction said. All right, for number 10, same thing as the previous one. We're doing a Tubex, so we're circling. We have an order of 35 milligrams. And then we have available, I guess we're going to assume that mepridine and Demerol are the same thing. Just don't get hung up on if somebody used the wrong label. But your order is 35 milligrams. Your available is 50. So a lot of these are all done the same way. But sometimes it's helpful just to do the repetition. Okay. So 35 over 50, I believe, is 0.7, but let me just double check. Yeah. 0.7 milliliters. Oops. Come on. Sorry, that was going to bother me. Okay. 0.7 milliliters, and then we would mark that on the syringe. So here's 0.5, 0.6, 0.7. And again, if they're telling you to mark something on a cup or a Tubex or syringe, you can almost guarantee that it's going to be on your, the answer will be on the Tubex, the cup, the syringe. All right. Valium, 7.5 milligrams is the order. You have Valium tablets, 5 milligrams available. How many tablets will you give? So first of all, you can assume that a tablet is scored, which means you can cut it in half. The only thing you need to know is, when you write your final answer, are you okay writing half, or do they want you to write 0.5? Okay, so you need to clarify that with your instructor. Just make sure that you're writing how they want you to write it. So 7.5, most people don't like to do math with fractions. Okay, especially when you're already dividing by something. So 7.5 over 5. So I'm just doing my order over half times my tablet. And 7.5 divided by 5 gives you 1.5. So your answer is either going to be 1.5 tablets, or they might want you to write it as 1.5 tablets. The reason I'm writing this both ways is because you're gonna have to make sure that you answer it the way that they want you to answer it. So if I were the one grading your test and I'm not, I would accept either answer, but there might be a particular reason why they want you to use the half instead of the 0.5. All right. Number 12, we're going to do the same way. The V-Cillin K, 500 milligrams by mouth, QID. How many, and then how many milliliters will you give? So we're going to look at, first of all, here's our order, 500 milligrams by mouth, QID, 4 times a day. Then I'm going to look at what I have available. It says 125 milligrams. Then it says 200,000 units per 5 ml. The 200,000 units is, if this was, let's say the order was 100,000 units, then you would use the units to do your calculations. But since it says 125 milligrams, the order's in milligrams, you're just going to use the milligrams per milliliter. So you can ignore the units here. Okay. So my order, my available, my quantity. Now make sure you pay attention. At this time, it's 5 milliliters instead of 1. So 500 times 5 divided by 125 will give me an answer of 20 milliliters. Oh, okay, there is a fluid output question here, so that's good. All right. So there's a little bit of nuance, and I went over this when we initially got together at the beginning of the semester with this, but it's always worth looking at. There's a couple pieces of information you're going to be given, kind of like your expected output, your replacement volume, okay, and then what was actually voided, okay. And so what I've recommended is it's almost similar to the order over half, except you're going to take your actual urine output over the theoretical or expected urine output, which is 120. And then you're just going to multiply by the replacement volume. And when you do that, 200 times 30 divided by 120, you're going to get an answer of 50 milliliters, which probably makes sense, right? Because if you're going to replace with 30 for 120 lost, if you actually lost 300 or 200, then it's going to be more than 30, but less than 60, right? Because 60 would be 240 milliliters lost. So it's going to be in that range, just to kind of estimate. But if you set this up the way, and I even wrote this in your review packet, it gives you at least a review that's posted online. It tells you to take the actual urine output, so the 200 milliliters in this case, over the potential or expected or theoretical urine output times your replacement volume, and then you'll get your answer. The other thing is just to kind of use your, just think through the question. So like sometimes you might get a situation where it says for every 120 lost, replaced with 30, but they only lost 100. Well, then your answer is going to be less than 30. Okay. But if it's more than 120, then you know the number is going to be greater than 30. So just kind of use that in case you kind of put these numbers in some other order. That should help you out at least with getting a range of where what the volume replacement should actually be. And then again, just practice. Sliding scale question. This is just, can you read the sliding scale? So patient's blood glucose before breakfast is 212. So I'm going to look at my glucose readings, and I'm going to look for the range that includes 212. So no, yes. What am I going to do? I'm going to give the patient 2 units of insulin. That's the answer. So you just write, give 2 units. All right, going back to what we've been seeing and what's the majority of your test is just kind of going through these types of things. So you have your order is 1.5 million units of oral swish 4 times a day. And then you can see our available is 100,000 units per milliliter. So I'm going to take my 0.000 over my 100,000 times 1 milliliter. So these are in units. I'm just, I'll just write U, even though that looks like another U. And we're going to look at the number of zeros we have. We have 1, 2, 3, 4, 5. And then I have 1, 2, 3, 4, 5. So I'm going to cross out all those zeros. This is just a shorthand way. And 15 over 1, you don't even need your calculator for this. So your answer is 15 milliliters. You see the kind of the advantage of using the crossing out the zeros thing? So remember, you just look for the fewer amount of zeros and cross them out between the top and the bottom. And then whatever's left, that's what you're going to plug into your calculator if you need to. But if it's something like this, you don't need to. All right. Well, marking the cup. This is actually considered a 2-step question. The reason it's 2 steps is because you're going to convert, you have to convert grams to milligrams or milligrams to grams. And so that's step 1. And then you do your math. So as practice, you can either do what I recommend is going from grams to milligrams. So you can just move your decimal place over 3 places and just get 250 milligrams. But if you need to see for practice, 0.25 grams. And then I'm going to convert grams to milligrams. We know that there are 1,000 milligrams in 1 gram. And that's how I get 250 milligrams as my order. You could have also converted 125 milligrams into 0.125 grams. So whatever you want to do is fine. You're still going to come up with the same answer. And the answer is, I'm going to take my order, the 250 milligrams over my available 125 milligrams times my quantity, which is the 5 milliliters. 250 over 125 is 2 times 5 is 10 milliliters. Don't forget to mark your cup, and also remember that your answer is usually on the cup. And in case you forgot, 1 cc is the same thing as 1 milliliter, so that's why you're seeing those as equivalents. All right, the next question is a reconstitution question. The next 2 questions are actually reconstitution questions. So it tells you that you have unison 1750 milligrams IM Q6H. So IM tells you it's an injectable, which means milliliters. And then it even asks you how many milliliters to administer for the 3-gram vial. So what we're going to do is I'm going to look at my 3-gram vial. Okay. And I'm going to use that information. So I'm not going to even look at what's happening here. Okay. So I'm just going to ignore because it told me to use the 3-gram vial. The 3-gram vial says that we have 3 grams of the medication, Unison. We have how much volume of diluent to be added, and then our withdrawal volume or our total volume. So I've said this on a previous thing. This, anytime you see that volume of diluent added, unless you are the one making and mixing the medication, you don't need to worry about that. And then for your dosage calc, drug calc, math stuff, you don't need it at all. So you need this number, your total volume, and you need this number, your total strength, and that's what you're going to compare to doing this math. Now, we're going to have the same issue that we had in the previous problem. We have to convert grams to milligrams or milligrams to grams. I personally prefer to make this conversion. So 3 grams is the same thing as 3,000 milligrams. And so I'm going to take my order, 1750, divided by, it's milligrams, divided by my available 3,000 milligrams times my 8 milliliter vial. So that's what's important. So it's not 1, it's not 5, it's not 15. This time it's 8. So I'm going to take my calculator. 1750 times 8 gives me 14,000 divided by 3,000. And I'm going to get 4.66666666666. So what am I going to do? I'm going to round my answer to 4.7 milliliters. Okay, so that's my rounded answer. The Pfizer pen question, I think, is a better example of a reconstitution question that you might see. So the order you can see is this 375,000 units. IM. As soon as you see IM, just know that your final answer is going to be in milliliters every 6 hours. And then it says to choose the strongest concentration. So that's important. And determine how many milliliters you will administer to the patient. So to kind of be consistent, you have 3 different milliliters of diluent added to a particular amount of Pfizer pen. And as I mentioned previously, these you can just ignore. We don't care about how much or how much volume is being added. That's just something, that's what's done in the pharmacy. What I care about is the total volume, or if it gives it to me, the units per milliliter solution. If I know what my units per milliliter are, 250,000 units per milliliter. So I'm just going to write units per milliliter, 500,000 units per milliliter, and then 1 million units per milliliter. Once I know what each of those are, because it tells me on the insert, then I know my answer, or at least I know what I'm going to be utilizing. So what am I going to do? I'm going to take my order, which was the 375,000 units. 1, 2, 3 units over my available, which is, it says the strongest concentration. So the other thing you got to make sure you know is that the stronger concentration means that there's more units per milliliter. So 1 million is the strongest. Times the 1 milliliter. I'm going to use my 3 and 3. So I take the least number of zeros, 3 up here. So I'm only going to take away 3 in the bottom. So 375 divided by 1,000. And you're going to get an answer of 0.375 milliliters. Now, because this number is less than 1, we're going to round to the nearest 100th place. So your answer will actually be 0.38 milliliters. The exception to all this rounding stuff is if they ask you to mark a syringe and your syringe went into the thousandths place, as long as you can mark it on the syringe, that's really what the limitation is. But if there's no syringe to mark and they want you to answer this, the best answer would be to round it to the nearest hundredth place, like it says to do. All right, here's another replacement volume question. So you can see it says for every 150 milliliters of urine output, replace with 40 milliliters of water. If the output for the last 4 hours was 325, what would the replacement volume be? So I'm going to do the same thing I mentioned before. I'm going to put the actual output, 325 milliliters, over the expected or theoretical output, 115 milliliters. I'm going to multiply by the replacement volume. I'm telling you, if you do it this way every time, it will work out for you. 325 times 40 is 13,000 divided by 115 gives you 113.0434. You would round that to the nearest tenth. And because the nearest tenth would be 0, we're just going to leave it at 113 milliliters. I just want to double check that I did that all right. Yeah, 113 milliliters would be the replacement volume for this situation, for this question. All right, next question. This is one that has a little bit of nuance to it. So it tells you your patients receive 36 units of regular insulin, 28 units of U100. Which solution amount will be drawn up first, and then select a syringe A or B and indicate the total correct medication level. So this is a little bit more straightforward with the questioning. So first of all, the solution to be drawn up first is always going to be regular first, and then the other types of insulin first. So which solution and amount? 36 units regular first. Okay, so R is for regular. So that's what gets drawn up first. Syringe A or B. So A is listed in cc's, B is listed in units. We're talking about units is our unit of measure. So units, that's the syringe we're going to use. So I'm going to add 36 and 28. So that's going to be 8 and 6. Well, here, we're just putting in the calculator. I think it's 64, but yeah, 64 units total, because it says mark and indicate the correct total medication level. So I'm going to look here. Now, previously, these were in increments of 1, but notice this is 60. This is not 61, 2, 3, 4, 5, because then we're at 70. So it's actually 60, 62, 64, 66, 68, 70. So since it's 64, total medication would be at here at 64 units total. Sometimes it asks you to shade it in. So if you did, you could just shade that in. All right, this is another question where we have to convert grams to milligrams. So the order is cimetidine, 0.8 grams by mouth, QID. How many tablets will you give per dose? And then we have available 400 milligram tablets. Remember, tablets are scored, so you could potentially give somebody a half tablet if that's what the order called for. I'm going to convert the 0.8 grams to milligrams. So that's 800 milligrams over 400 milligrams times your tablet gives you 2 tablets. Now, if you're looking at some of these things, you're like, can I just like say what the answer is? They want you to show your work. So just make sure you're showing your work in some way, shape, or form. But, and then just use the fact that you already know the answer as a guide that you're doing it right. Hopefully that made sense. All right. Haldol, 1 milligram is the order. By mouth, BID. Available is Haldol half milligram tablets. Okay. So again, remember, if it's a tablet, it's scored. It could be delivered in half. Now, this is where things get a little bit interesting, because you might be saying like, well, it says 1 milligram, it's half milligram, or you might just automatically go like, okay, I'd give them 2 tablets, which is the correct answer. But look at what else it says. And I almost missed this. How much to give per day if we're giving them the dose twice a day. Okay. So I'm going to take my 1 milligram order divided by my available. That's per tablet. That equals 2 tablets. And because I'm giving it twice a day, my per day is 4 tablets. All right. A couple more here. Lanoxin, 500 micrograms is what we have available. Then you'll see that Lanoxin, which is also known as digoxin, is available in 250 microgram or 0.25 milligrams. So that basically just tells you the same equivalent. Okay, there's 250 micrograms per tablet or 0.25 milligrams. Now you might be wondering, like, I didn't know that was micrograms. So like you'll see this is the same thing as this. Okay. So it's like it's called the Greek letter mu. Okay. But they both mean the same thing. So since my order is in micrograms and I have my available in micrograms, that's how I'm going to set this up. 500 micrograms. I can write that over my available 250 micrograms times, these are tablets, will give me an answer of 2 tablets. Notice up here, it doesn't say per day or per dose. If it doesn't say either, then it's per dose. Okay. That's why this is 2. All right. Another injectable, morphine, 12 milligrams IM. So remember, when you see IM, you know that your answer is going to be in milliliters, even if it's missing or not there. So like if you're doing this on ATI or the NCLEX, or you are doing this somewhere where you don't know your units, if it's an injectable, it's milliliters. And what we have available is 15 milligrams per milliliter. So I'm going to take my 12 milligrams divided by my available of 15 times my quantity. $12 divided by 15 is 0.8 milliliters. And then if it asks you to mark that on a syringe, you would just do that. Don't round that to 1 milliliter. The answer is 0.8. And last but not least is this last question here on Aldomet. It says your patient has ordered Aldomet 300 milligrams by mouth, TID. How many milliliters will you give per dose? Now, here's the thing. When it says by mouth could be capsules, tablets, or it could be milliliters, or it could be teaspoons, as we saw that as an example. So the by mouth, you just have to pay attention to what it's available in. So like, let's say it didn't tell you, it just says how much would you give per dose? You could arrive at the fact that it says oral suspension and that the available dosage is in per milliliter. So when you see that it's per milliliter, you know that it's a liquid. And so that's how you assume. You don't assume that it's a tablet or a capsule if it tells you it's per milliliter. So I'm going to take my 300 milligrams, my order. I'm going to divide that by the 250 milligrams, my available, times my 5 milliliters. Now, I will say this right here, like the 5, 15, 8, and 1, like this is the commonly misstepped with oral suspensions, is that you put some other quantity in there than what should be there. So make sure you put the correct quantity and you're getting that right from the label. So 300 times 5 is 1500 divided by 250 will give you an answer of 60 milliliters, which is the same thing as 2 ounces or 4 tablespoons or what, 3 or 5. Yeah, I was trying to get fancy with the teaspoons. I think that's 4. I said 4 tablespoons, which is the same thing as 12 teaspoons is what I was looking for. So you'll notice that we went through all of that, all 25 questions. Obviously, I know how to do these, and I can set them up and I kind of make it seem easy, but it can be easy for you too. It's just a matter of practice and then figuring out where you're stumbling on, and then I can kind of help navigate you through that. But it took us less than an hour to go through it, even with me stopping and explaining and talking through it. So you have plenty of time to take this test. And in the meantime, just practice. And if you want alternative questions, just go through these and just change the orders, and then you can get alternative calculations. And if you have a question about one, then that's a great question to ask me, and you can let me know and I can kind of help you out, even if that's via email or when we get together again on Thursday, whatever works best for you.
Dr. Rad, should that last one be 6 milliliters or 60?
Let me just double check. So 300 times 5 is 1500 divided by 250. Oh yeah, you're right. I'm sorry.
That's all right.
Thank you. That was
yeah,
helpful.
I just want to make sure. Okay, thanks.
Oh, you're good. That's helpful because I made the mistake. So yeah, it's 6 milliliters. Thank you. All right. Are there any questions on any of the practice test questions?
Thanks for going over